Hello, welcome to the video. In this lesson, we're going to be looking at section 2.3, where we're going to find what is called a focus of a parabola. So, up to this point, when we are graphing a quadratic function or we're graphing a parabola, we have exclusively looked at parabolas that either go up or down. So we either have parabolas that have a right side up U shape or an upside down U shape. There are other variations to creating a parabola. The other ones that we're going to look at today on top of upside down U shape upside and right side up U shapes is U shapes that either can go to the right or they open up to the left. And that is where finding the focus of a parabola is useful, which then also means we have new general formulas for us to solve. So what we have here in these two diagrams is we have parabolas that either go right side up or upside down, open to the right or open to the left. Every single vertex in these parabolas are going to be located at the origin, 0, 0. So when your parabola is at the origin, you are going to look at two separate equations. You're either going to look at equations that look like this, or you're going to have an equation that looks like that. Now, in my opinion, uh, I normally like to isolate the variable that's squared. So you don't have to do this if you don't want to. So in my personal opinion, I prefer to write this equation as x squared is equal to 4p y. I just like it because it gets rid of a fraction and your value for p is in the numerator. It makes it a little bit easier to solve for, in my opinion. But if you see it this way and you're good with it, by all means, use that as well. But for the majority of these lessons, I'm going to focus on this general equation here. So anytime that your parabola is either right side up or upside down, it is going to be x squared is equal to 4py, where p is the location of the vertex. So, or not the vertex, the focus. So if you notice here, they say the focus is at 0, comma p. So wherever the value of p is, that is going to be your focus. The focus is a point that is in the curvature of the parabola, and the idea is that it's equidistant from each part of the parabola as we with respect to the vertex. Oh, sorry. So this distance here is actually going to be the same distance as this line that is called the directrix. Okay, so we have a focus and we have a directrix. The directrix is always going to be on the outside of the opening of the parabola. So if you see in this diagram here, the parabola opens up. That means that the directrix is on the other side of that opening. It never intersects the parabola, and it is always going to be the opposite value of p. If p happens to be a negative number, that means that my u shape goes upside down with respect to x squared. That means my value for P is below the x-axis, which then means that my directrix equation is above the x-axis. Looking at the other way that you can sketch a graph of parabola, either where it opens to the right, like this one here, or this one opens to the left, like this one here, the focus and the directrix are now along the x-axis. And if you notice, the difference is what is squared. Up here, x was squared, and in this one, y is going to be squared. And again, I prefer to rewrite this one with the isolation of the variable that's squared. So this is going to be y squared is equal to 4px, where again, p is my value for the focus. And if p is positive, it's opening up to the right like it is here. And then my directrix is on the opposite side. So now it's a vertical line. So now you see that it's x equals the opposite of p. If you notice here, the directrix here, because it was a horizontal line, it's y equals the opposite value of p. When it's opening up to the left, that means p is negative. So that means that it is, my focus is on the left-hand side, which makes x negative, and my directrix is on the right-hand side, where it's the opposite of that. And again, we'll look at examples that'll help us determine where these points are for each parabola. So in this particular example, they're asking us to identify the focus, the directrix, and the axis of symmetry of negative 4x is equal to y squared. All right. The first thing you have to be able to identify when you're looking at the equation is which way is my parabola going to possibly open up? Is it going to open up or down? Or is it going to open up right or left? Since my variable y is the one being squared, I know it's either going to go to the right or left. All right, just by referencing this chart here, because y squared is there. That's why I know it's either going to open up to the right or left. So from here, what we have to do is I have to look at the other side of my equation, this negative 4x. So essentially, remember the general equation is y squared is equal to 4px. So essentially I want to say is, all right, negative 4x is equal to 4px. So in this process, I'm going to be able to determine what my value for p is. So I'm going to divide 4x to both sides. This gets canceled, this gets canceled. X get canceled in the numerator and denominator, and negative 4 divided by 4 is negative 1. So negative 1 is my value for p. So now that I know my value for p is negative 1, I now know that my graph is going to open up to the left because p is negative. So I do my graph here. I'm going to go, oh, negative 1. So this is negative 1. So negative 1 comma 0 is my focus. So negative 1 comma 0 is my focus. My directrix is the opposite of that, so it's going to be 1, but because it's going to be now a vertical line, it's going to be x equals 1. So here is my directrix. My parabola is opening up to the left, like I said, so it's going to go here and here. And my axis of symmetry is just right along here. And so that is a horizontal line. So in this particular instance, it's going to be y equals 0. So anytime my graph goes from right or left and my vertex is at the origin, my axis of symmetry is going to be y equals 0. When it goes up or down, it's going to be x equals 0 when my vertex is at the origin. So now here they want us to write an equation of the parabola shown. Okay, so what they give us is they give us the vertex, which is at the origin, which is great. And they give us a directrix. They don't give us anything else. So my vertex and directrix distance is 1, 2, 3. So they're 3 units away. All right. Now, anytime that we talked about directrix, we talked about it being the opposite of P. So that means if the directrix is at x equals, I'm sorry, this is going to be a horizontal line. So this is not x, it is going to be y equals 3. So that means that my value for P is the opposite of that, which is now going to be -3, which makes sense because my parabola is shaped in the negative upside down U shape. Because it's an upside down U shape, we are going to be dealing with an x squared equation. So we are going to be using the general equation x squared is equal to 4py. And all we got to do is write the equation. Now that I know that -3 is p, my equation is x squared is equal to -12, because 4 times -3 is -12, for -12y. All right, if you have it like this, great. If you want to write it with respect to the variable that's only got 1 degree, you could also have wrote this as y equals -112 x squared. Either one works. So here are different examples of them asking us to find the focus, directrix, and axis of symmetry, and they're asking us to graph it. So it's very similar to the first example we looked at. Let's take a look at number 3. Okay, so number 3 has us with -y is equal to x squared. So because my x is the one being squared, I know my parabola is either going to go open up or open down. Because my y is negative, I know it's going to be opening down. So from here, we have to figure out what my value for P is so I can discover what the location of the vertex is. So using the general equation, x squared is equal to 4py, I can now say that, well, x squared is -y. So I can say that -y is equal to 4py. And then in this particular instance, to solve for p, I'm going to divide 4y to both sides. So y's get canceled. Here and here gets canceled. So I'm left with a -1/4 is equal to p. So now that I know that -1/4 is p, I can say, well, all right, looking at my graph here, knowing that my vertex is at 0, 0, it's opening downward, so I'm just going to write that in. My focus is always a part of inside the parabola, and this is going to be location 0, -1/4. So that is my focus. So my focus for this one, let's write it right here, is going to be 0, -1/4. My directrix is going to be the opposite of P. So the opposite of P is positive 1/4. And it is, in this case, a horizontal line here. So this is, since it's horizontal, it's y equals positive 1/4. So y equals positive 1/4. My axis of symmetry, in this case, it's going to be vertical for the axis of symmetry. So that is x equals 0 in this particular instance. And I graphed this parabola equation. If you have additional questions on 2 or 4, please leave a comment or let me know. I'm more than happy to work those out if need be. All right, last part of the notes is they are asking you to write an equation of a parabola with vertex at the origin 0, 0 with the given information. So in this particular instance, for like question 5, all they gave us was that the directrix is x equals -3. Now, what I like to do is I like to draw out what is given to us. So right off the bat, I'm just going to go here and get my graph out and say, okay, directrix x equals -3. So -3 is right here. X equals means it's vertical. So my directrix is right here. Knowing that my directrix looks like that, that means that my vertex is here, which they told us, which was 0, 0, and my parabola is going to open up away from the directrix like so. And since it opens up to the right, that means we are dealing with an equation that has y being squared. So that means we're dealing with the equation y squared is equal to 4px. Now, in order for us to write the equation, we just need to figure out what the value of p is. Well, value of p in this particular instance is going to be the opposite value of the directrix. So p is going to be the opposite of -3, which is +3. So in this example, my equation for the directrix, my equation for the parabola, my apologies, is y equals +12x. Or you could write it as x equals 1/12 y squared. Either or. All right. I like this one the best, but our textbooks has you using this one, but either one works. If we look at number 6, will do make this my last example of the video. If you want to see 7, please let me know. I'll do it in the future. So looking at this one, this tells me that the focus is at -2, 0. So if I were to draw this out, -2, 0, let's say -2 is right here. I plot this point. All right, my vertex is again 0, 0. My parabola is always going to be going with the focus. So that means that it's opening up to the left. That means we're dealing with this same general equation. Y squared is equal to 4px. Now here, they tell us that it's the focus, and the focus is my value for p. So I know that this is going to be y squared is equal to 4 times it by -2, which is -8x. So this is my equation. You could also have written it as x equals -1/8 y squared. Either or. And that is being able to find or look at the focus of a parabola. Hope this helps. Till next time.